Hello everyone. In our last session, we have discussed about trigonometric ratios and trigonometric ratios of some specific angle. Now starting with the trigonometric identities, here we'll be learning three trigonometric identities where we'll be learning first about sin square theta plus cos square theta relation, then sec square theta and tan square theta relation, following which we'll also discuss about cosec square theta minus cot square theta relationship. Let's start with the first identity, which is sin square theta plus cos square theta is 1. Now, in this case, if you want to prove it, that how we are getting the value of sin square theta plus cos square theta as 1, then we'll draw a triangle ABC and we'll use Pythagoras theorem. So here what we can say that, we know that AC square equals to AB square plus BC square. Now if I'll divide both sides, so on dividing both sides by AC square, we will get is AB square plus BC square upon AC square, which will be equals to AC square upon AC square. Further, it can be written as AB square upon AC square plus BC square upon AC square, which will be equals to 1. Now here, if we'll talk with respect to an angle, suppose we say that angle C is theta, then AB upon AC is sin theta, which is opposite upon hypotenuse, so we can write it as sin theta whole square, and BC upon AC will be cos theta, so we can write it as cos theta whole square, that is 1, and so we'll get sin square theta plus cos square theta equals to 1. Now, when we talk about the application part of it, so this is the straightforward relation that sin square theta plus cos square theta is 1. But while solving trigonometric identities questions, we'll also have to convert sine in terms of cos or cos in terms of sine. So for that case, what we need to remember is that sine square theta, we can write it as 1 minus cos square theta, which also can be written as 1 plus cos theta into 1 minus cos theta. It will help us when we have to cancel between the numerator and denominator. So it is very important for us to understand how we can write in the factor form. Second one is cos square theta. Cos square theta, we can write it as 1 minus sin square theta, further which can be written as 1 plus sin theta into 1 minus sin theta. And then as we know sin square theta, we can even find out sin theta also by just taking square root of it. So this is about the first identity, sin square theta plus cos square theta, which is equals to 1. Now let's prove the second identity, which is sec square theta minus tan square theta is 1. Now in order to prove this identity, what we are going to do, we are going to take the same Pythagoras theorem statement and we'll write it as that we know that AB square plus BC square equals to AC square. Now on dividing both sides by BC square, we'll get is AB square upon BC square plus BC square upon BC square, which will be equals to AC square upon BC square. Next, we can write it as AB upon BC. Here it will be opposite upon adjacent, which can be written as tan theta whole square plus BC square upon BC square is 1, and AC upon BC, it will be hypotenuse upon adjacent, which we can write it as sec theta whole square. Now tan theta whole square can be written as tan square theta plus 1, which will be equals to sec theta square. Now which can be further written as sec square theta minus tan square theta, which will be 1, and that is how we can prove. Going further, when you talk about that the uses of this identity, so this is straightforward form where we'll be using it. Other way, as we can see that it is based on a square minus b square identity, even we can write it as sec theta plus tan theta into sec theta minus tan theta, which is 1. And so we can say that sec theta plus tan theta will be 1 upon sec theta minus tan. This is the second. Or also we can write it sec theta minus tan theta equals to 1 upon sec theta plus tan. So that means what we understand here is that sec theta minus tan theta and sec theta plus tan theta are reciprocal of one another. That means if I know one value of it, we can find out the other. Apart from that, also we can write it as sec square theta will be 1 plus tan square theta, and tan square theta will be sec square theta minus 1, which can be written as sec theta plus 1 into sec theta minus 1. So this is what this second identity is all about. So the uses of it we'll be seeing while solving the question. Moving to the next identity, which is cosec square theta minus cot square theta is 1. In order to prove the third identity, we are going to take again that we know that AB square plus BC square equals to AC square. We'll take angle C as theta, and on dividing both sides by AB square, what we get is that AB square upon AB square plus BC square upon AB square, which will be equals to AC square upon AB square. That can be written as 1 plus BC upon AB. BC is adjacent and AB is opposite. We can write it as cot theta whole square, which will be equals to AC upon AB, that is cosec theta. We can write it as cosec theta whole square. Now this can be written as 1 plus cot square theta equals to cosec square theta, and this is the identity what we need to know. If you will write it also as cosec square theta minus cot square theta, we'll write it as 1. So now as we have proved this identity, we will see the further uses of it. So the way we have seen for sec square theta minus tan square theta, here also we can write cosec square theta minus cot square theta as cosec theta plus cot theta into cosec theta minus cot theta is 1. And so we can write that cosec theta plus cot theta equals to 1 upon cosec theta minus cot theta, which we can take it as 2. And if we'll write cosec theta minus cot theta, that will be 1 upon cosec theta plus cot theta. So again, what we understand here is cosec theta plus cot theta and cosec theta minus cot theta are reciprocal of one another. So if we know the value of cosec theta plus cot theta, then we can find out what will be cosec theta minus cot theta and vice versa. Going further, if you'll also see the results of it, like we can say that cosec square theta, we can write it as 1 plus cot square theta, and cot square theta can be written as cosec square theta minus 1, which further can be written as cosec theta plus 1 into cosec theta minus 1. So we'll see that which form of this identity we need to use when we'll get the question. So these are the three identities which we need to know and learn. Now moving to the next part, we'll be discussing the questions based on it. So let's talk about the question now. So let's start with the first question, where we have to find that write all the other trigonometric ratios of angle A in terms of CK. That means we need to write the other trigonometric ratio where only sec A trigonometric ratio is involved, no other trigonometric ratio should be there. So if you talk about sine of angle A, we can write it as square root of 1 minus cos square A, which can be written as 1 minus 1 upon sec square A. And that further it can be written as sec square A minus 1 upon sec square A, and which can be written as sec square A minus 1 upon sec A. Now since we know how we can write sine A in terms of sec A, we know the reciprocal of sine A is cosec A. So cosec A will be equals to sec A upon square root of sec square A minus 1. Next, let's talk about how we can write tan and cot in terms of sec A. So if we'll take tan A, we know that it will be square root of sec square A minus 1 from the identity what we have learned. And then the value of cot A, as it is a reciprocal of tan A, we can write 1 upon square root of sec square A minus 1. Following which, if I have to find cos A, which is the reciprocal of sec, we can write cos A is 1 upon sec A. And this is how we are going to write all the other trigonometric ratio in terms of sec A. So remember, they can ask you the question to write other trigonometric ratio maybe in terms of cos A or tan A, cot A, cosec A or sin A also. And using these identity what we have learned, we are going to write in the required form.